Farid. I'm going to talk about my PhD thesis, which is ESR3 in this other project. I'm coming from Tehran, Iran, which I assure you it's not so far from Europe. And actually, it's this city quite a big city with like a metropolitan and with some nice views sometimes when you don't have the pollution. So this is the outline of my presentation, the background, supervisors, timing, and the objective of my PhD, and also the expecting results. So from 2011 to 2015, for 4 years, I did my bachelor degree, which is 4 years in my country. So normally we have a thesis at the end of it. So my thesis was about discrete element simulation in rock falls, and you can see the picture of this. And then I moved to France. I did my master M2 in civil engineering and geomechanics in Université Grenoble-Alpes. I did my master thesis in laboratoire 3SR or 3SR with Chino Vigiani, Pascal Villard. I also again use a numerical method, and I use a discrete elements method as the preferred method. And here is
my master's degree in civil engineering and geomechanics from Université Grenoble-Alpes. I did my master's thesis here in ESR laboratory. During both my master and bachelor degree, I have focused on numerical simulation of mechanical phenomena by using discrete elements method.
So I don't want to take the time because I know that we are very in a hurry and I don't have that much time. So directly I will go to give you a summary of my project. I will have 3 supervisors, two from Unilim and another one, Dr. Domonon from Université de Poitiers, which we will work on a DIC with Poitiers, and with Damien we will focus on numerical simulation by the help of Mark for supervising this project. And my secondment will be one in Leoben, and the other secondment as the industrial part in the auto company. We already had some exchange. With Dr. Gruber about the potential of the topics that we could work in Leoben, and also with Dr. The place that I will work is European Center of the Ceramics in Limoges, and this is a very fast and compact timing of my PhD, which started in January. So we already work on this topic about 1 month and a half, and we start the bibliography studies. And the industrial secondment will be around June and July in 2018. And the next year, from like February or July to July, I will be in Leoben in Austria to mostly work on micro-wedge splitting and do some numerical simulations with other softwares rather than the software that I will use in Unilim. And in December 2020, hopefully I will defend my thesis. Here is a very short Gantt chart of my my PhD thesis and the work package that I should work on. As you can see, I will start by work package 3, which is like about numerical simulation and the microstructures simulation by using discrete elements method. Then I will have some parts in improvement and improvement of the measurement tools that we are already discussing about this by the help of the Robert and Diana, because they are also involved in this work package. And then some part in work package 2, and for sure at the end of my PhD in the work package 4. About my PhD, the objective is to develop a numerical tool for the use of this ATHOR project by using discrete elements method, and to investigate the properties that we can achieve from microstructures to use them in the microstructures. So it's micro to macro scale problem that previously mentioned here, and also to focus on thermomechanical coupling in the simulation. We will develop a tool to use in Granu for better simulation of the thermal shocks and fracture mechanics in the C++ and Python environment. And we will try to focus on the coupling of it, maybe in the finance elements, to compare the results and maybe to validate the other aspects that we are focusing on. For example, the complex boundary conditions. And this is the sample of the environment of the Granu software that you can see. It was about two-phase solid material and the crack closure. The results that we expect is, as Dr. Priera mentioned, to validate this simulation, and we can do it in two aspects generally, with thermomechanical properties, like to have coefficient of the thermal expansion and the validation of Young modulus and the fracture toughness. And also we can do it with a microscopic observation that we will have under maybe SEM with fracture coefficients and thermal loadings that might be applied to this specimen. All of these things will done to optimize. All of this will do to optimize the microstructure design of the material of the refractories to achieve better and high performance materials, specifically in the refractories or in other brittle materials. And there will be some innovations that could be interesting for industrial partners, like the fastidious calibration of the key parameters, which is the thing that is a kind of barrier to widely use the discrete elements code with the industrial partners and engineers. And thank you for your time.